Assalamu alaikum. Anunno.
হ্যালো স্যার, শোনা যায়?
Okay. Welcome and thanks a lot for joining with me in the class. Now, Anunno, I will discuss gravitational field. Okay, and you know all A2 level physics is one part in the syllabus. Gravitational field. Okay.
Yes, sir. Yes, sir.
You can observe, you can see something here which I will provide now. You can see the title, gravitational field. Okay, I don't know, can you see? I guess you are seeing this.
Yes, sir, I
Anyway, no
can see.
problem at all. Now we will start our class robustly, fairly and wonderfully. This is the title of this chapter, gravitational field. Gravitational field. Okay, for understanding the gravitational field, I may show you some picture. From those picture you may understand actually what I am going to say, going to deliver. Okay, look, gravitational field we will discuss. You can see a plane is flying. Okay, a plane is flying. You can see here, this is gravity. Okay, it means
Yes, sir.
Earth is attracting this airplane downward.
Yes.
This force today we'll discuss. Here this another force, thrust another force, lift another force. But now I'll discuss this force, gravity. Okay, understand? Earth is attracting
Yes,
this
sir.
aeroplane. That type of force I'm going to discuss. I'm going to say. Okay. Another picture you may notice now. That is actually, look here, another picture. From this picture, what do you understand? What we can feel?
It's a picture of the solar system.
Solar system. Okay, fine. Solar system. That means it's a solar system. You know, because during our class 6-7 we saw this. Here, this is sun, and around the sun, various types of planet are rotating. Okay, suppose such as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. But our question is, how do they rotate around the sun? How?
They're attracted to the sun.
So we can ask a question, how these planets are rotating around the sun. That our thinking point. Actually here, gravitational force. By the gravitational force, there is a attraction force between sun and a planet, or among the sun and planet. That means this force I am going to discuss. That is gravitational force. Okay, that is gravitational force. And here also we have to think another point, that is actually circular motion. Okay, at the center point sun, others planet are rotating, and our target here to understand, to feel the gravitational force. Okay, gravitational field, gravitational related some quantity we have to learn by heart here. Okay, I have shown you two pictures. One is airplane where you can see force of gravity. Here you can see force of gravitation or force of gravity, same. Here look, another picture. From that picture you may understand. What can you see? Okay, another picture you can see. Okay, it's another picture. From this picture you can see sun and earth. Sun, same that solar system, also we can see here. I have shown this especially sun and earth. Okay, there is a attractive force between sun and earth. Okay, and that force will measure by this formula. This formula our understanding point: F1 F2 equal to G capital M multiple small m upon r squared. Okay, we can see this formula, and this formula will understand. That is F1 equal to
Yes.
F2 equal to G capital M small m upon r squared. It's actually Newton's law of gravitation. We'll understand this. We'll deduction this, and we'll do a lot of numerical problem related to this formula. And this formula we can apply between sun and earth. Okay, between the sun and earth, the attractive force F1 F2 equal to G capital M small m upon r square. I don't know. Okay,
Yes, sir.
you have seen
Yes.
already three pictures, and from three pictures you've understood what I am going to say. That is gravitational field or gravitational force.
Yes.
We'll discuss. Anyway, you may see another picture that may give you profound concept. Okay, let me show that. This is also another picture, gravitational force related, and from this picture you may understand very clearly what is gravitational force. An apple is falling down, and a baby is flying, but force of gravity is acting downward. Okay, fine. This, and apple is falling down due to force of gravity. And could you tell me, I don't know, whether it is
Yes, sir.
contact force or non-contact force?
There is no contact force.
Just see this picture. What can you see here? This is Earth
The satellite is orbiting.
orbiting. Okay, fine, nice. This is satellite, and it is rotating around the Earth. How?
Yes.
How it is rotating? It is rotating due to
Earth's gravity.
okay, fine, gravity. Fine. That means we are going to understand this concept. I have tried to show you a lot of picture. Through those picture, I am trying to give the essence of this chapter. Then I will go to algebraic problem. That means formula, picture, year question, etc. etc. But from these graphics, from this photography, you have understood. We are going to understand the gravitational field, gravitational force. Okay. Now let me show you something related to the. Okay, fine. Here one word we will learn, that is actually gravitational field. Gravitational You have got a lot of picture, and from those picture you have understood.
Yes, sir.
Okay. Now try to understand this gravitational field. What is the gravitational field? What is the gravitational field? We look here. This satellite is rotating under the force of attraction of Earth. That means this satellite has to stay in the area of attraction, not beyond the area of Earth. Okay, that means try to understand what I am saying. Look, that means gravitational field is a region of a space where a mass experiences a non-contact gravitational force. Suppose this is Earth, okay, it is Earth, and around the Sun, this area, in this area, something experiences a force. This area is called gravitational field. This area is called gravitational field. But this place is not gravitational field. I have said this area is the gravitational field of this Earth. In this region, something feels attraction by the Earth. So is the gravitational field. A gravitational field is a region of a space where a mass experiences a non-contact gravitational force. And you know non-contact force. What is non-contact force? Actually, gravitational force, electric force, magnetic force, these are non-contact. Why? Because for feeling this force, there is no necessity of contact. Okay, there is no necessity of touch. That means
Yes.
normally something can feel this force. Those are non-contact. Gravitational force non-contact, electric force non-contact force, magnetic force non-contact force. That means there is no necessity of touch. Without touching, something is feeling. That is non-contact gravitational force. Okay, fine. Look, types of force field. Types of force fields are created when certain objects interact. Force field are created when certain object interact. Gravitational field, why we can feel gravitational field? Due to masses. Okay, this is our target point. Due to masses, we can see gravitational field, and this is our topic. And due to charges, electric field is not our topic, but we are saying the field. Okay, another magnetic field is due to moving charges. For moving, okay, it's our not topic. Our topic is gravitational field. Why do we get gravitational field? For masses. Okay, fine.
Mm.
Now, I want to try to understand now types of gravitational field. Just now you have understood gravitational field. Now we are going to understand types. Okay, fine. Uniform field. Uniform field. Okay, which is uniform field? Look at this picture. This is uniform gravitational
Yes.
field because they are parallel and equally spaced.
Yes.
Equally spaced. Equally spaced. Equally spaced. The separation distance equal and parallel, like this way. They are uniform. If you look at this picture, then you may understand what I have said. Okay.
Yes, sir.
Okay, fine. Let me show another thing. Now, this is radial field. We are saying about field. Just now I have said what I have said now. Uniform field,
Uniform field.
radial field, radial field. If you look at this picture, they can you understand what is radial field. This is like this. Such type of force of line due to gravitational field, these are radial. So excuse me, this is radial. Okay, I don't know.
Yes. Yes, sir.
Radial field, as like as this, and you can understand this is a line of force. This is line of force,
Force.
and line of force direction is actually vector quantity. Vector quantity. That's why we have shown the direction, and we have mentioned the direction by this arrow side. And try to understand, sometime or frequently A2 physics question paper may ask you to draw the line of force due to the gravitational field of Earth. Okay, then you will draw such a picture, and for drawing this picture you may get one number.
Yes.
Okay, gravitational force depends on distance from the center. Look, this Earth has a center. The gravitational field depends on from the center. From the center. And field lines is spread out from the point Mars. Okay. That means imaginary. Actually, we show the gravitational field by this line of force. by this line of force, by this line of force,
Yes.
by the, and what is point mass? Look, this is Earth. It's a giant thing, very big.
Yes.
If
Yes.
we consider the mass of this Earth at a point, then we will say that is point mass, nothing else. Just it's an imaginary concept. It's a big thing. Due to easy calculation, we have to think this point mass. If we consider this point mass, we will do same thing as the big mass. Okay, because anyway, that means field lines spread out from the point mass. Here, this is center. We can consider whole Earth at the center. That means
Yes.
we'll think that is point mass. Very small, very tiny. It's like an imaginary calculation for doing the calculation easy. Okay, spread out of the point mass. Fine. Try to remember this figure. Try to remember this figure, and from this figure you may understand the radial field, and you may say the force of line due to the Earth. Okay, nice. Next slide. Okay, next slide. Try to understand what I am going to say. This is field line. Now I am saying field line. What does field line mean? What is the meaning of field line? This line, this line, this line. What does it mean? We are going to learn that. Okay, fine. This arrow show the direction in which the force acts. Look, this direction along this direction along this direction along this. That means force is acting along this direction. Okay.
Yes.
Now, let's try to for this question answer, you will get 1 mark. Sometime or frequently, your 80 physics question asks you to draw South Pole, North Pole. South Pole, North Pole. Okay, how? Here, this is gravitational force. This is gravitational force along this direction. That means from this point, something is going,
Yes.
and finally they are going into. Which are going into? Line of force.
Force.
This is the line of force going into this pole. It is called, what is called? Can you say me?
South Pole.
South Pole. Okay, nice. This is south. A-level question gives this type of question. Okay, South Pole and North Pole.
North Pole.
Then you will get 1 mark. This is north. This is south.
South.
Am I right?
Yes, sir.
Okay, fine. Well, actually, 2025, such question came probably. Okay, 2025. Have you understood what I've said? 2025, one question asked to show North Pole and South. 2025. Recently, such type of question came. Okay. Anyway, now Now we have understood. Oh, no. We have something closer field lines. This what you type. Excuse me. This what you have to remember and you have to understand. Closer field. This closure fuller field. Closure field. These are closure. These are closure. Very close to each other. There is stronger gravitational field. Okay.
Yes.
Very close to Earth's surface, the field is almost uniform. Further away, it becomes radial. From this concept, 2025, a question came. Okay, in 2025,
Yes, sir.
why at the close to the surface, gravitational field is uniform. Such way, one question came in 2025. 2025 May June A level question. Okay, becomes radial and further away, this line of force become radial. Okay, and from this section we've understood closer line and separated line. Look here, here will gravitational force will be more?
No.
No. Good. Anyway, here radial, Earth's gravitational field radial, very close to the surface, it is almost completely uniform. Now we will understand this equation. Gravitational field strength. This word. At first, we know field. Then I said types of field. And then I said field lines. Lines. What does the line mean? And now I am going to say gravitational field strength. This word I am going to say. What is the field strength? Just from this formula, we may understand the field strength. And I gave you an example. Suppose this is R. I said gravitational field. Gravitational field is the area. In this area, some object can feel the force of attraction by the earth. That is why this region is gravitational field.
Field.
But we have to measure the amount of gravitational field strength. How much powerful this gravitational field? How we could find out that? By this. That is theory. In my first session or in my first page, a slide, I said gravitational field. But now I am saying Gravitational field strength. And what do you mean
Yes.
by strength? This is the strength. Strength means how much powerful or how much strong. That will be measured by this formula. For a mass, the feeling of attractive force amount F due to 1 unit mass, what is the amount of attractive force? That is F upon M. It is actually gravitational field. And if you know the force amount, the mass amount, we can find out the gravitational field
Field strength.
strength. And the unit of gravitational field, Newton per kg. Gravitational force on a small object, N. That is unit Newton. And mass of a small object is a small object.
Yes.
The object which is feeling the force of earth, this is the M, and F is the force which is exerting earth. Earth is exerting
Yes.
that amount is force, and is the object which is feeling. Okay, fine. That means we have to remember this formula, and from this formula we will get the field strength, and there is a definition. Probably I will say later. Anyway, Gravitational field strength is the force, it's a force actually, per unit mass exerted by gravitational field on an object. The value is constant in uniform field, but varies in radial field. You can use the following formula to calculate the gravitational field. This G equal to F upon M. Just now I have showed you. Okay, F is the force exerted, M is the mass of the object in the field. Now another formula of gravitational field strength, that is as like as this. This is another formula. G equal to capital G, capital M and R square. Here capital G is actually gravitational constant, and capital M is the mass of earth, and small r is the distance between the earth and object. If question gives you the mass of earth and the distance between the earth and the object, then you will find out the gravitational field strength by this formula. This is another formula.
Yes.
This is another formula, and we may get how. We know all. What do you know? We know G equal to F upon M,
F by
or F equal to mg. This we know.
yes.
F equal to mg we know, and this we know is the law of gravitation. F equal to, I will deduct this later, but probably you might get in your O level. F equal to IGC, F equal to G capital M small m upon R square. This law very popular and very famous and very known to you. This F and this F same. Then we can say mg equal to capital G capital M small m over R square. Here m cancelled, so finally we get z equal to capital G capital M upon R square. This formula we have got such way: G equal to capital G capital M upon R squared. If you know the value of R, M, G, we could easily find out the value of field strength G. It has another name. Do you know? This G has another name. Do you know?
Uh, I don't
acceleration
know.
due acceleration due to great gravity.
Oh,
Acceleration,
yes.
acceleration, acceleration due to gravity. But here, excuse me, we are saying here gravitational field is strength. Gravitational field is strength. G. Okay, Ananda, just now you have known two formulas. One is G equal to F upon
Um,
M, and another one this. You may do mathematics simply because just now you have known the formula. You have understood the direction of the formula. G equal to F upon small n. Another G equal to capital G capital M over R square. These two formula you have known. Anyway, if I say,
yes.
suppose if I've said the force F equal to 100 Newton and mass of the object which is staying in the field, mass of the object, suppose 10 kg. What will be the field strength? You can do this very simple.
10, sir.
10. Okay, guys. But that means you have understood. Now, suppose you know the mass of the earth. Do you know the mass of earth?
No, sir.
That is 6 into 10 to the power 24 kg. And value G, the value of G 6.67 into 10 to the power minus
11.
11. Okay, you've got G, you've got A, and 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 radius radius of the earth 6.4 into 10 to the power 10 to the power 6 meter. Now could you tell me gravitational field distance? What is the gravitational field distance?
The gravitation field strength.
You can find out very simply. How? You will find out now. Gravitational field is Hello. Okay, fine. That means you can find out the gravitational field if question gives you the value of capital M, capital G, and the distance R. You can find out
Yes.
now
Yes, sir.
by this formula. Capital G, capital M, R squared by this formula. Can you see me?
Yes, sir.
Okay. G equal to G equal to capital G and okay, ganito na kadyan. The value of G is 6.67 into 10 to the power minus 11. And is the value of What is the value amount of capital M? I said capital M 6 into 10 to the power 24.
Yes.
And I said R. What is suppose the object at the surface of the earth, then what will be the distance?
Radius of the earth.
Radius of the earth. This radius of the earth. So what is the radius of the? What's the amount of radius of the earth? I said 6.4 into 10 to the power 10 to the 6. Okay, 10 to the 6. Now do the calculation by calculator. Then you will get the value of 9.8. What will be the unit? For unit, you will get 1 mark. If you don't give
Unit.
unit,
Newton per kilogram.
Newton per kilogram. Right. Newton per kilogram. Okay. This is the way of calculation of G.
Yes, sir.
In 2A, you will find out the amount of G. One is G equal to capital F upon small m. Second one, G equal to capital G, capital M upon R squared, whether it is small or capital. When the object stays at the surface of the earth, then you will use the 6.4 into 10 to the power 6. Suppose the object stays at a height from the surface of the earth, then how we will find out the G? Just we will add the height with the radius, then we will get
Yes.
okay. Now 1 hour has gone. Will you continue today?
So I can continue.
You can continue. Okay, fine. Now offset this. You can F equal to F equals here F equal capital M, small m, capital G, R square. This formula. Do you know this formula?
Yes, sir.
This formula is very easy, and from this formula we can say our Newton's law of gravitation and Newton's law of gravitation between point masses. Here
Yes.
we will use point mass for doing the calculation easily. Okay, point mass, and here G is the capital G is the gravitational constant, capital M, is the mass of the Earth or another planet, could be. Small m is the mass of the object. R is the distance between Earth and object, or between two objects,
Yes.
whether it is Earth or other planets in the solar system, or in this room you could find out the force of gravity between two objects.
Yes.
And from this formula you can say a definition which is very important. That formula, what is the definition? What is the definition then? What is that definition? That the force of attraction between two objects, the force of attraction, Newton's law of gravitation states that the magnitude of the gravitational force between two masses is directly proportional to the product of the masses and inversely proportional to the
The
square
separation.
of the distance between two objects.
Yes.
That is the definition. Will I write this?
Yes.
Newton's law of gravitation. Gravitational force between two objects or between two masses is directly proportional directly proportional to the product
Yes.
product product of masses. Okay, product of masses and is inversely, one mark, inversely proportional pro inversely proportional to the square of the inversely proportional to the square of the distance to the square to the square square of the distance. Got it?
Yes, sir.
Okay. This actually we have shown by this formula F equal to G M upon R square. Okay. Look, first I wrote this. Where this okay. This formula we've got this formula from this definition. We can write another just now I've said in the definition this force of accretion magnitude is the directly proportional to the product of masses. That means first one like this way. One is earth mass, other is of a object mass. Anyhow,
Yes.
this is the proportion. Proportional. Proportional means, what do you mean by proportional?
I will say constant.
Directly proportional means if it increases, this will be increased.
Yes.
If this decreased, this will be decreased.
Decreasing.
This is the meaning of directly proportional. And I said F is proportional to the inversely proportional to the square of the distance. Here R. Since I have written at first R, thus I have given again R. The distance between two objects R. This is the relation. Magnitude of force is inversely proportional to the square of the distance. Okay, let me draw a picture. How can I draw? Very simple. And in first slide I showed this picture. In second or third slide I showed this sun picture and then the earth picture. And then since I have said this M and I have said this small m, and try to understand how do you measure the distance. Here you have to be clear. We have to measure the distance between two objects
Centers.
from the center
Yes.
of the earth, and this distance will be considered. Okay, the distance between the center. Okay,
Yes.
this distance I have said R, and is capital mass and is a small m, and force of accretion between these two objects this direction, this, and for this object the force of attraction, this, it is exerting such a way, and this object exerting the force such way, such direction. And this force, if we say due to the m1 f1 and due to m, if we say f2, the force of attraction, this will be equal.
Yes.
Okay, this is it.
Yes.
And finally, this formula F equals, since we have right now equal, so anyway, let me draw another line. Let me write another line, if magnitude of force R square. Okay, now now F equals proportional sign. I've written here proportional sign. Now I've written equal sign. That means here G.
Yes.
This is the gravitational constant due to writing equal. And M is M, capital M is M, small m, R square. Finally, we've got this formula, and it's very easy and very known to you, I guess, and familiar to you. After all, you could get this during O level. Am I right?
No, sir. We didn't have this in our level.
Oh. This formula okay. Now could you find out could you do any numerical problem if I say the value of G, value of M, value of small m, and distance between the capital M
Yes,
and
sir.
small m? Since
Yes,
you
sir.
since you understood the equation from my direction, from my description, from my elaboration, from my writing, and
Yes.
I've said what is G, what is capital M, what
Yes.
is small m. Moreover, I've said the R, distance, and I've drawn the picture. How could you find out the distance between two objects from the center? From the
Yes.
center. It's very
Yes.
basic concept. Always you have to determine the distance from the center of the object. So sometime or frequently you have to add something with R. Then you have to calculate the gravitational force, velocity, etc. etc. You will give it. But basic, you have to determine the distance from the center. Okay, this concept you have to have.
Yes.
Anyway, you have got the formula F equal to G upon, in various way to physics question paper come. Okay, you have to understand this step, and from that system you will apply various type of formula from your concept.
Yes.
Then you will perform your numerical problem.
Yes.
Okay. Here, suppose the mass suppose mass of two objects, or or I can give you a figure. From that figure, you may find out the magnitude of force. In fact, I showed you some picture in the slides. We could observe again that. Anyway, let me show you again those picture. Those picture I showed you by Canva. Okay, okay. Look, this is sun, this is earth. If you try to find out the value of S, then you will apply this formula. For this region, you have to know the mass of earth, mass of sun. You have to know the mass of sun, mass of earth,
Earth.
and you have to know the distance between earth and sun. You
Yes.
know the distance between sun and earth? Probably question give you that. Moreover, question provides you the mass of earth and sun. So there is no big problem. Am I right?
Yes.
Concept is the prior concern. If you know the concept, if you know the direction of a formula, then you can apply actually the information which would be provided by the step, by the creative question. Okay. Even though I should show you a mathematical problem. Okay, so suppose this is a object, its mass is 20 kg, 20 kg, 20 kg. No,
Yes, sir.
its mass is 2 kg, and distance between this 10 meter. Could you find out the magnitude of force? Can you do this mathematics?
It's 2.668 times 10 to the power minus 11.
If equal to, oh, you have found this. Anyway,
Yes, sir.
okay. Now you've got a small g equal to gravitational field instant, and you've got the magnitude of the force between two objects by the Newton's law of gravity. Am I right?
Yes.
And we have done 2 or 3 mathematics, and you have to know for this chapter V equal root capital G capital O R. What is this? You will know later, and you know. Okay, let me show this picture. Meeting is being transcribed. Okay, you'll know this formula later. Today is sufficient. Today I'll not continue more. You have learned this. You have learned this. Am I right?
Yes.
And later you'll learn this. You'll get this. You'll get this. You'll get this formula. I'll get this formula direction. Okay.
Yes, sir.
And this is gravitational force related formulas. Okay. And later I am giving you the course plan. Okay. Today
Okay.
my lecture has been completed. This phase for electric field you will get this chapter related concept, and you will get you will get capacitance based concept, you will get electromagnetism, you will get AC theory, okay, you will get
Yes.
quantum mechanics,
Yes.
nuclear physics, astrophysics related concept you will get in astrophysics, okay.
Yes, sir.
And today I've given 1 hour and 20 minutes, and I tried to show you a QT question, but exam based question, but for doing that we need a lot of time, which I may show you. That is actually like this. Canva. What is Canva? Canva. This is Canva. Okay, look. Oh no, this is actually question which you may see in the examination,
Exam. Yes.
but I've not made you understand this concept. Next class I may deduct those formula. Which are those? This like this. Gravitational potential. Have I said about gravitational potential?
No, sir.
I've said gravitational field, gravitational strength, line of force, Newton's
Yes.
law of gravity, and I have done mathematics related to small g, related to capital F. Okay, these three mathematics I have done. But you exam question like this pattern, which concept is gravitational potential. Next class I may make you understand.
Yes, sir.
Potential at a point, such a question may come. For the definition, you will get 1 mark. For doing mathematics, 3 marks. For another small math, 2 marks.
Yes.
For higher concept, just 1 mark. For higher concept, but answer very small, 1 mark.
Yes.
Secret type. But you have to have deep concept, deep notion. Otherwise, you can't do this. Anyway, this is the question pattern of your A2 physics for the chapter for total mark 9. Actually, mark varies. Anyway, this is the question pattern, and I may solve this in the next class. And this concept is potential, gravitational potential.
Yes, sir.
Okay, all know. That's all today. I have recorded this video. I have recorded this lecture. If you feel necessity, you may request me. Then I may send this. Okay. Have a
Okay, sir.
understood? No.
Yes,
Okay.
sir.
Thanks a lot for joining with me and convey this message to your mother.
Okay, sir.
Do you know this? Your next class when?
Take care, sir.
Okay. Have you enjoyed today's class?
Yes, sir.
Have you understood clearly?
Yes.
Have I made you understood profoundly?
Yes, sir. I understood.
Have you got the basic of this chapter?
Yes, sir.
Okay. Since I have made you understand through the graphical system, pictorial system, then I am 100% confident that you have understood clearly. Otherwise, for understanding the physics is quite tough without
Yes.
providing the concept through graphics, through picture. At first, I showed you some slide, and by those slide, I try to make you understand what our discussing point. Okay, I showed you 3 or 4 picture at first. Those were related to satellite and Earth. Apple is falling,
Yes.
and the force between Earth and Sun. And at first slide, I showed you solar system. Am I right?
Yes. Yes.
From the solar system, you could understand our basic point. Moreover, most of picture were space related. But if you think in room, will you apply that formula? Could you apply? Can we apply the formula in our room?
No, sir.
No. We can apply here. We can apply this force between 2 objects in this room. Anywhere you can apply this. It's just
Okay, sir.
can apply. Just we need mass. We need 2 objects. Who has masses? Due to masses, we get force of gravity. The object which has mass, those objects will give the force of attraction. Okay, mass related. Since table has mass, chair has mass, building has mass, you have mass. That's why not? this formula will be activated. Why?
So it will work.
It will work. Okay, that's all today. Assalamu alaikum Ananto. Please knock me.
Walaikum assalam.